Okay, so you can see the title there. We are solving equations with exact solutions now. This is going to be a reminder of some things that you have met previously but may well have forgotten. And hopefully, as we go through it, this will kind of fit in with our solving equation stuff. And I'm going to bring in radians and degrees here. So there are two key triangles that you need to be aware of. One of them is this, which is a nice equilateral triangle. And we're actually going to split it in half to form two right-angled triangles. We're actually only going to worry about one of them. Now, because it's equilateral, this angle down here is 60 degrees. And this angle up here is half of a 60 degrees, so that one is 30 degrees. Now, if we blow that triangle up nice and big, that's our 60 degrees, that's our 30 degrees. There's our right angle. If the side of our equilateral triangle is 2, then this side is also 2, but we're only got half of it. So that is 1. A little bit of Pythagoras, 2 squared. Take away 1 squared is 3. So this side here is the square root of 3. It's just using our c squared equals a squared plus b squared. So we need to square root 3 to get this length. So that triangle there gives us some key facts. And these are facts that you need to know, need to learn. And when you do learn them, they will come in pretty handy on a regular basis. Now, first thing I'm going to do is I'm going to list degrees and I'm going to list radians. I'm then going to list what sine of that angle is, what cos of that angle is, and what tan of that angle is. And we're going to read these off this triangle. So if you can remember what this triangle looks like, you will be able to fill in this table. So we're going to start with 30 degrees. Now it's handy to remember, well, 30 degrees is a sixth of a half turn, and a half turn is pi. So pi is 180 degrees. Divide that by 6, we get 30 degrees. So it's the same as pi on 6. 30 degrees, pi on 6 are the same. Sine of that angle. Well, sine of 30 is opposite over hypotenuse. So that is a half. Cos of 30 is adjacent over hypotenuse. So that is root 3 on 2. Or root 3 over 2. Tan is opposite over adjacent. So that is 1 over root 3. And that is the first row in our table. Second row in our table, we're working with 60 degrees. Now, if 180 degrees is pi, and I divide 180 by 3, I get 60. So pi over 3 is the same as 60 degrees. Sine of 60 is opposite over hypotenuse. So that is root 3 over 2. Cos of 60 is adjacent over hypotenuse, so that's 1 over 2. Tan of 60 is opposite over adjacent, which is root 3 over 1, or just root 3. And so we have 2 rows in our table. These are things that we will use in a minute, but these are really key ones to be aware of, key values to be clear on. Now, the other triangle that we're going to look at, and this is another really common triangle, is if I have an isosceles triangle where that is 1 and that is 1, and this is 45 degrees, that is 45 degrees, that is a 90-degree angle. Again, Pythagoras, c squared equals a squared plus b squared. So that's 1 squared add 1 squared is 2. So the hypotenuse is the square root of 2. Again, we can now add it into our table, this time with 45 degrees. So if we've got 45 degrees, that is quarter of 180 degrees. So 180 degrees is pi, quarter of it, pi over 4. Looking at our triangle, sine of 45, and it doesn't matter which of the 45 you use, you'll get the same answer. Sine is opposite over hypotenuse, so 1 over root 2. Cos is adjacent over hypotenuse, that is 1 over root 2. And finally, tan is opposite over adjacent, that's just 1 over 1, or 1. Now, this table of values is going to come in really, really handy, and it's one that I know with my class I got you to write it down already, but you might want to add that radians column in, because actually what we're going to do in the next one is we're going to solve, or next little bit, we're going to solve some equations involving radians and sines, coses, and tans. So have that as a little note. If you want to remember it, remembering these two triangles is a good way to just memorize what the table is. You will find other tricks online, but I think just memorizing the table, memorizing the triangles is easier probably than memorizing the table. Now, I'm going to stop there, and in the next video, we're going to use this to solve some equations and give exact solutions.